Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get started on lesson 8.3.1. We are now going to start looking into some geometry. We're going to start by looking at angles. So this particular lesson is called Introduction to Angles, and let's just get to it. It says, have you ever watched a dance team performing a routine in which each person moves and spins in perfect unison? Each dancer always knows exactly how many times to turn in the direction in which he or she should end up facing. In this lesson, you will develop ways to describe turns by investigating angles and look at angles inside shapes. All right, so first question for you to think about is what does it mean to do a 360 and what does it mean to do a 180? You know, maybe if you've thought about this while dancing, or maybe you think about it when you're on skateboards or skiing, perhaps. Some people do jumps and do a 360. I'm not sure how many people do a 180 while skiing, but you could definitely do it on a skateboard. So what is a 360? If you are thinking a 360 is when you turn completely around, that would be correct. So since 180 is half a 360, a 180 would be if you turn around halfway. Okay, so this part in class, I would like, all right, everyone stand up, and do a 360. And so everyone would like stand up and they'd completely turn around and they'd be facing me just like they were when I gave the direction. Then when I say do a 180, everybody turns and now they've got their backs to me. So, you know, just to get us thinking about these different degrees. And so what I would like for you to do is, what's it say here? It says, work with your team to design a clear and consistent way to draw diagrams to represent these movements. Be sure your diagrams include something that shows the direction a person would face at the beginning and at the end of the turn, as well as the size of the turn in between. Okay, so what I'd like for you to do is, you know, just try and pause the video and draw some kind of a diagram, whether you show a person standing there with a circle going around them, however you want to do it, be creative. Draw a picture of what a 360 would mean, what a 180 degree turn would mean, what a 90 degree turn would mean, and then a 45 degree turn. Go ahead and see if you can formulate some ideas in your head and spend a few minutes doing something. It doesn't have to be an earth-shattering perfect picture, something to show what this number of degree turn, how it could be drawn as a diagram. Okay, go ahead and take some time with that. Okay, so I can imagine you might be a little bit confused at how you're going to draw this diagram. Why don't I reveal the 360 degree one for you and then see if you can complete the 180, 90, and 45. If you've already done it, then wonderful. If not, pause and continue after I do the reveal for 360 degrees. This is how I chose to think about it. I started thinking like a sort of a perspective. This is where you would start, so you're like facing in this direction. And then the person here would go, let's say they'd turn and they'd face back, and then they're turning around, and then eventually get back to where they started. So 360 degrees, if you started here, right there, you are going all the way around that circle, and you're stopping precisely where you started. So that's a 360 degree turn, a full circle. Okay, so if you were to use this as your diagram, what would, and this is like an aerial view, this is like a side view, what would a 180 degree turn look like? Well, I'll go ahead and reveal what I did for this one as well. So I figured you're starting right here and you're stopping right there. Okay, so this represents your, like, I don't know what I did there. Oh, okay. So the red kind of where we start and the blue is where we stop. Notice how we started here and went all the way around and stopped there. Here we're stopping at this point. And so this would be like 180 degrees right here. Maybe I'll write that in for you, label that. This one would be 360 degrees. This is 180 degrees to go from here to here. So what would 90 degrees look like if you use this kind of a diagram? And then what would 45 degrees look like? Okay, and I'll pause for a second. You go ahead and pause and see if you can complete your diagrams if you didn't already do so. All right, let's see if you've got something similar to what I have. 90 degree turn would be a turn where you start here and then you stop right there. So here's your starting point. There's your ending point. That forms a 90-degree angle. That's supposed to be degrees there. And 45 degrees is half of 90, right? So if you started here, right, start here, you'd stop somewhere approximately there, and the aerial view would look something like that. So that would be considered like a 45-degree angle. So I guess to put it into words to describe what that would look like, you'd turn 1/4 of the way around the circle, right? This is 1/4. 1/4 of 360 is 90, so that would be 1/4 of the way around the circle. Excuse me. 45 degrees would be half of that, so that would be 1/8 of the way around that circle. So we are going to do a little bit more exploration, and a lot of people don't have protractors. And it seems like whenever I give them out every single year, so many of them get broken. So it's like, well, it's not even worth it using the protractors anymore because they always get lost or broken. But you know, we can still do some estimating and get pretty close, like within 5, maybe 10 degrees of a number of degrees, just by estimating, just by using a little bit of logic. So today's lesson is going to be a little bit about that. So when your teacher asks you to do 360 degrees, how did you know what to do? 360 refers to the turning in a full circle. That is turning completely around and right back to where you started, right? The most common unit used in measuring rotation is degrees, and there are 360 degrees in one full rotation around a circle. So there is a copy of this resource page on the Google Math class page. You can print that off, or you can just draw a circle. You know, if you get a glass out of the kitchen and set it on your paper and you trace it around, you can usually find round objects you can use to trace a circle on your paper. So you can do that as well. It says, work with your team to estimate the number of angles in degrees. Be prepared to explain how you determine your estimate. And hold on for a second. I'm not sure why I put that there. Got it. I think I missed a direction in here. It says, get a copy of this resource page, which looks like this, and it says, maybe I should just remove this for a second because I added those. It says, work with your team to estimate the number of degrees in this angle right there. Okay, so if I'm going to estimate the number of degrees, we just did an activity where we showed what 90 degrees and 45 degrees look like, right? This is a 90-degree angle. This is a 45-degree angle. And this is about half the 90, right? So I'm looking at this and I'm thinking, does that look like it could be about half of the 45 degrees? Does it look like maybe it's a little bit more? How many degrees would you estimate that to be? And I'm thinking, all right, if you said it was exactly half of 45, half of 45 is going to be 22.5 degrees. But does that maybe look like it's a little bit more than half? I don't know. So if I'm going to round it off, and I'd say maybe about 25 degrees. Somewhere between 22.5 to 25 degrees is probably what that angle measures. And there's that picture right there. So once again, you take, here is 90 degrees. Here is 45 degrees. Yeah, I'm more that I look at that, I think that's probably 22.5 degrees, right? Because this is the 45-degree mark. This would be half of that, so probably more like 22.5. So, you know, if you break this down and just cut it in halves, and then take these and maybe cut these into thirds and whatnot, you'd be surprised the number of angle measures that you can come pretty close to estimating. So that's what we're going to do right now. On the next resource page, we are going to estimate where the 30-degree mark will be, where the 45-degree mark, where the 60-degree mark is. You already know how to find the 90-degree and the 180. I think that's already given. And then 135. Okay? So how will we partition these? How big is this angle in degrees, and can we subdivide it any further? Those are some of the things to think about as you're working through this process. So I will get you started. I'm going to start with a should we do a color for this one? Let's color coordinate them. I'm going to make the 90-degree angle in the color of red. So I'm going to write 90 degrees right there. And so your task is to find, were we supposed to find 45? Yeah, 30, 45, 60. So I would start by finding 45. Then I would find where the 30-degree mark is, and after you find that, you should be able to find the 60-degree mark without too much trouble. If you can find the 45-degree mark, the 135-degree mark shouldn't be too much trouble either. And you know what? While you're at it, what if you were to find the 120 mark and the 150 mark as well? That might be very helpful to find all of those measures. And if you print out this page and then use your ruler to make these lines relatively straight, this page actually serves as a protractor for you, right? You can just use this as your as a mock protractor. So go ahead and take some time and see if you can put in all of those measures, an estimate of all those measures. All right, so I'm going to do 45 degrees in blue, and that's about the halfway point, right? 45 is half of 90. So let's go ahead and take this guy and let's color it blue. 45 degrees. In fact, you know what I want to do? I'm going to go and I'm going to do, I've got the 45 degree. I'm also going to do the 135, because when you add 45 to 90, you get 135. So that's going to be about the halfway point right there. So let's go ahead and put this guy in, and that is now 135 degree mark. Okay, so now let's find where the 30 mark is, and I'm going to do this one in green. The 30 is about a third of the way up. So if I break this guy into 3 equal parts, does it look like it could be evenly spaced there, about 30 degrees? I think so. I think that's about 30 degrees. And so this one would have to be 60 degrees. And if I continue going to here, does that look like it could be right around another 30 degrees? Measure that arc right there. That looks like that would be about 120 degrees. And then we would continue down to here, and this one would have to be about 150 degrees. Let's do these guys in green. No. Yes. So this would be your 30 degree mark. This would be your 60 degree mark. This would be your 120 degree mark. And this would be your 150 degree mark. Now, I wonder how close I came. I'm going to go ahead and, ooh, nice. Move this guy over to here. Did I come pretty close? I did. Look where 30 is. That's pretty close. 60 is right on. 120 is perfect. 150 is perfect. Wow. Good estimation, Mr. Aarons. Proud of you. All right, so we could do that, and we could pick it up into, even more. We could take and do a 15 degree. Let's do a 15 degree. Hold on for a second. I've already done this one, and this one, and this one, and this one. Now let's do this guy in black. No. Yeah, we'll just do 15 degrees. And then maybe 75 degrees. And then maybe 105 degrees. And then maybe 165 degrees. Okay, so halfway mark between the 30s would be the 15s, right? This one's already there, and this one would be here, this one would be here, and this guy would be right around there. So now we're going to go ahead and change these guys to black. So this would be your 15 degree mark, 30, 45, 60. There's your 75. Here's your 105. And there is your 165. So now I'll go ahead and put those guys in. 15 degrees, 75 degrees, 105 degrees, 165 degrees. Okay, so you can make yourself a pretty decent protractor. And now that you are going to use this for measuring angles, you can probably within a few degrees, right? If it's 10 degree, it's going to be somewhere around here. If it's a 62 degrees, it's going to be somewhere around here, and so on and so forth. So all used for estimation. And even if you don't use this piece of paper, now that you've got a good visual strategy on how to estimate angles, you can really get some pretty accurate measures. All right, so it says get a protractor from your teacher or not. Maybe just use the tool that we just used. And it says compare it with the one that you made. Oh, okay. In what ways are they similar and which ways are they different? Well, whatever. Mine's perfect. That's how it's similar. Okay. So Hunter used the protractor to measure. Oh, by the way, this is a stoplight problem, which means Hunter made a mistake somewhere. Let's check and see what it is. Roger used a protractor to measure the angle at the right. He got 60 degrees. Why is that not a reasonable measure? Well, what do we know about acute and obtuse angles? Remember that acute angles are angles that are less than 90 degrees. And obtuse angles are angles that are greater than 90 degrees. So this can't be 60 degrees because it's obtuse. So my guess is that they probably used the wrong number line on the protractor. So on this protractor, let me actually show you here. Notice that you've got a number line that starts at 0 on the left side and goes on the outside of the protractor. Then you've got another one that starts at 0 on the inside and goes to 180 on the inside. And so what you need to do is you need to look at where your vertex is and then determine, okay, it's opening this way, so 0 would be here. Always want to start with vertex and then one of the lines going to 0 and open it up. This would be 90 degrees. So actually, I don't even know how he got 60 degrees. He should have said like 67 degrees. That would be more accurate. But technically, it's not accurate at all because he's using the wrong number line. It should be about 100, what is that, probably 113, 120. It's closer to the 110, so about 113 degrees would actually be closer to our measure. So you have to place the origin on the vertex and then follow the number line. And basically, you just know if it's an obtuse angle, you've got to follow the number line that gives you a number that's greater than 90 degrees. If it's an acute, you've got to follow the number line that's going to show it less than 90 degrees. So we use a little bit of logic as you do this, but actually, let me go ahead and go back here again. This is the key part. This part of your protractor is called the origin. That has to go on the vertex. And then one of your rays has to line up perfectly with the 0. So once you've got your protractor set up, then you can read it appropriately. Okay, so it says here for problem number 56, estimate the angles formed in the diagrams below without measuring. So this is a little bit harder to do when you don't have the math book. Because with the math book, you can actually kind of like set it down and you know, set up a protractor on top of it. Being able to do this with your with a computer is going to be a little bit tricky. So I think what I'm going to do is I'm going to help you out here, and I'm just going to go ahead and set this little mock protractor right on the origin, and you tell me what you think the measure is. Okay? So go ahead and pause as we do this. I'm going to go to each one. Now I'm going to move over to this guy, and now you got to be careful because that's an acute angle, right? So if you were to say 145 degrees or 135 degrees, that would be way off because that's an acute, right? This one's the obtuse one. So this is acute, so it's got to be less than 90 degrees. So kind of work like that's 0 and that's 90 and work your way backwards. What would this guy be? And then, ooh, this one's going to be a little tricky. Let me rotate this. Actually, I'm going to rotate it like this. Let's do it like that. So one of those rays would point, so that would be like 0. So what would this one have to be? It's clearly not going to be like 160 or 150. It's got to be something closer to 20 or 30. Okay? So make your decisions on all of those. And I'm going to go ahead and do the reveal now. If you're not ready to make those decisions yet, you pause and write in all your answers. But I'm going to reveal. This one looked like it was close to 135. This one looked like it was close to 45. This one is pretty obvious. Everyone knows that's 180, right? And then this one, what did we say? Something pretty close to 20 or 30. I said 20 degrees. All right, so now we're going to do the same thing, but we're going to take and measure an angle of a shape that's a polygon. So this is a trapezoid, this is a triangle, this is a hexagon. Let's go ahead and do the exact same thing and estimate the measure of each one of those angles, and then go ahead and we'll take the protractor and see what the actual measures are. What are the estimates? Go ahead and write down what you think they are, and then I'll reveal what the actual measures are by using our protractors. Go ahead and take a little time working on that. All right, so should start with the estimate. I said that was about a 45-degree angle. Let's see what it actually is. It actually looks like it's closer to 50 degrees, right? And, you know, sometimes you got to take a little line. It's like, okay, where does that go there? Yeah, it goes to about 50 degrees. So we'll call this, stop it. Stop. What's going on? Okay, get that out of there. We do the reveal. Stop! Got to yell at my computer a little bit. It's not behaving appropriately. Yep, so that's about a 50-degree actually. For this one, my estimate was about 40. No, it wasn't. What was it? Was that about the halfway mark? 45? No, that's probably closer to 60 degrees, I think. Yep, I thought about 60 degrees. What's the actual? Hey, it's about 58 degrees, actually. Pretty close. And this one right here, we thought it was obviously obtuse, and maybe that's about 120, somewhere in the 120 range. And what is it actually? So this one, I'm going to put the origin in there. Those are the crosshairs. Make sure that line is perfectly with 0. And now we've got to use the outer line. And this one looks like it's going to 120, almost exactly. Let me take a line here and extend it. Is that 120? Yeah, I'm going to say that's 120. Exactly. Ah, those dogs. Reveal. Reveal. There we go. 120 degrees. All right. So you can estimate angles, and you can actually pull out a protractor and get the exact measurement. But what I tend to do is when we don't have protractors in the class, I tend to allow students a little like 5 to 10%. Usually 5% is close enough. If you can't get an estimate within 5%, maybe you're not thinking about it enough. So yeah, take your time, and if I'm going to let you estimate on your measures, try and get within 5%. And that's it. We are done with our lesson for today. All right, so let's move on. I'm pretty sure we'll have a check for understanding for this. Take care. Bye.
Hey, feeling good.